When teaching and training people to become meteorologists, meteorology service, requires trainees to hold a university science degree in maths and physics. First and foremost, meteorologist is a science, and we need people who are capable to become meteorologists to apply scientific thinking that is taught at school and university that understand the state of the atmosphere. Let's look at specific examples of why maths and physics are so important to meteorology.
The maths in fog. Forecasting for aviation you may think is simple as far as the public is concerned, but it's certain for airlines, pilots and passengers to be safe in their travel. There are many meteorological scenarios that impact flying, e.g. turbulence, thunderstorms, crosswind whilst landing and airframe icing. One of the most dangerous is fog because the pilots need visibility to land. When our aeronautical meteorologists forecast fog in the Australian airports, they have used maths and physics, including the principles of dynamics, radioactive processes, and graphs of cooling rates and statistics of airport climates.
Probability and statistics. The introduction and basic concept of probability and statistics are introduced in maths at school. Meteorology is an inexact math and science. Every day at the National Forecast Centre, scientists are forming hypotheses about the future weather outcomes around Australia. The concept of hypothesis testing is taught in Year 12 mathematics with statistics and further development.
Geometry. There are many amazing shapes in geometry. Example, the cardio. Another is a spiral. A spiral is found in nature in shells and plants. A special type of spiral is the logarithmic spiral. It's related to meteorology. It's used in a technique to understand the intensity of a tropical cyclone based on satellite images near the eye of the cyclone. The meteorologist accesses the top temperature in the segments of the spiral, providing an objective gauge about the cyclone intensity. This branch of math is important in many sciences. An example related to meteorology is spherical trigonometry, in which any location on Earth can be specified in terms of latitude, longitude and height above the Earth's surface. Our weather radars make a lot of the principles of trigonometry to determine the location and movements of rain targets.
Rates of change. The understanding of rates of change occur all the time in meteorology. It occurs on many scales. Example, in less than an hour with the rainfall of temperature, during the time of a cold few days, it could lead to a major disaster. To describe the motion of air using techniques of fluid mechanics, many equations containing too many difficult answers become harder to work out.
Numerical analyzing. With the benefits of a new branch of mathematics called numerical analyzing and increasingly powerful computers, we can now solve the equations accurately, up to several days ahead. Just now, accuracy depends on the state of the atmosphere at the time, but sometimes it's possible to predict the development and a path of disaster before it's formed.
Information. If yourself or a person you know is thinking to become a meteorologist and you want to know what they need to practice, tell them to continue with their maths and physics throughout school and continue then throughout university.
Future. In the future, it's going to be harder to predict the weather because of the greenhouse gases, which cause the weather to have more frequent severe weather conditions. With the technology we have now and the technology to come that will be more advanced, scientists are able to predict the drastic weather conditions. With our environment getting worse each day and destroying our ozone layer, there will be more extreme weather conditions. Example, earthquakes, cyclones, volcanic eruptions, dangerous storms and extreme temperatures.